In this video, we are going to find this speed limit for the car when it negotiate the bend of a level curved track like this. So, at this position of the car on the track, it is going exactly tangential to the path like this. So the speed of this car when negotiating the bend is taken as v in general. So in finding the maximum velocity for the car, the maximum limit of the velocity for the car for the safe negotiation of the bend, we are going to find the physics behind that. So the physics behind this situation is a circular motion of an object. When anything is going around a circular track, it is accelerating towards the center of the circle. So this car is going in this circular track, therefore it is accelerating towards the center of the circle at that point. So let us go into the physics behind the situation. So if we mark the forces acting on the car at that position, so the weight acting downwards like this, the normal reaction acting upwards like this, the weight is taken as mg and the normal reaction acting upwards is taken as n. The frictional force is present here. The frictional force can provide the necessary centripetal force for the safe negotiation of the car. Therefore, the frictional force can provide that necessary centripetal force for the safe negotiation to keep that path circular. This frictional force is taken as F like that. Let us treat that situation mathematically. So for the circular motion, towards the center using the Newton's second law of motion, the resultant force in a given direction is equal to the mass times the acceleration in the same direction. So when applying this equation towards the center, the acceleration is the centripetal acceleration that is given by v square by the r, which is the radius of the circular path, times the mass. This is equal to the resultant force, that is only the frictional force like this. This is labeled as equation number 1. So this equation is going to determine how the force varies with the speed. So the force increases as the speed is increased. Therefore, at the maximum limit, say V max, the maximum limit of the speed, the force has to be its maximum value, possibly, which is equal to the limiting frictional force mu s n. So we can put that value in the place of the force in the first equation, therefore becoming that equation, say mu s n times m v square by r. This is an interesting result because there is not a final result because n is not here. This car in the situation is not moving up and down, you can see that. Therefore it has to be equilibrated in the vertical direction. Therefore this car has no acceleration, and therefore these two forces acting vertically have to be balanced. This n acting upwards equals the weight mg acting downwards. by putting that value in this n place, you can write that with a more simplified way as like this. You can see here this m will drop out of the equation, becoming it more simplified for the square of the maximum speed. Actually here it would be mu s g, this is taken to that, then you get r here. This is an interesting result that you can subject this v expression the root the mu s g r. So this is what the interesting result. It is going to determine the maximum speed limit for the safe negotiation of the band. So the maximum limit, this term is very important. This is not the speed, that is the maximum limit of the speed. So this equation provides an information for every riders. Every drivers going with any vehicle have to negotiate the band with this same limit. So every driver should keep that speed without exceeding the limit of the Vmax. So this right side, look at that right side of the equation. This does not include any vehicle parameters. This is radius of the band, does not depend on the type of the vehicle. This mu s, this does not depend on the type of the vehicle possibly. Therefore this Vmax does not depend on the type of the vehicle. Every vehicle has to keep that turning safely this band without exceeding this speed limit. Thank you very much.